This is Lab 4, Oscillations. The purpose of this lab was to examine the motion of a spring mass system where the mass swings in an oscillating arc from the bottom of a spring. The resulting model was used to predict the motion. The result is that the predicted motion was relatively close to the experimental motion. However, there was a slight variance causing the predicted curve to be slightly to the left at all times of the experimental curves. These could have been caused by unaccounted for outside forces as well as human error. This is the video used to track the motion for this experiment. There is also information given which includes the mass at 0.402 kilograms and the final length of the spring to be 0.70 meters, as well as the time between video frames, which was 10.53 meters per second. The rest of the information needed was gathered using trackers. Starting from the main fundamental principles, Newton's second law as well as the energy principle were applied to this situation. The period of one oscillation on average was found by taking the time of 3 oscillations and dividing by 3 to find an average. From there, the spring constant was found, and then the initial spring length could be calculated using the following formulas. From here, each of the following equations were entered into the code in VPython. The initial information was inserted as well. Here are all the formulas that were used. You can see here where the initial information was inserted, including the mass and the initial position, which were all found using tracker, as well as some of the constants. And here is where the equations are entered, including the kinetic energy and the potential energy of both the gravity and the spring. And in the loop is where the majority of the calculations take place. These include the force of gravity, which is the negative mass times gravity, the force of the spring, which is S, which is the difference in the initial spring length and the final spring length, as well as the spring constant, F net, which is the force of gravity plus the force of spring, as well as Newton's second law, which is velocity final equals velocity initial plus F net over mass times delta t, as well as the position, which is the final position equals the initial position plus the velocity times delta t. Each of the energy changes were calculated by using K equals 1/2 mv squared, U of the spring is 1/2 ks squared, and U of gravity is mg. And the difference is found by subtracting the final from the initial. And then it's plotted using this graph plot function. And you can see when this code is ran, there are 2 spheres moving around the spring. One is the object of predicted motion from the VPython model. The other is the experimented motion, which was found by extracting the position data of the mass and importing the information to the code through a CSV file. The red and the blue ball end up in relatively similar spots at the end of these oscillations. When looking at the oscillations of the graph, the blue line represents the change in kinetic energy. The red line represents the change in potential spring energy, and the green line represents a change in potential gravitational energy. The yellow line in the middle represents the total change in energy. This proves that the change in energy will be 0. This also proves that no work is being done on the system. For the first what-if question, this does fulfill the energy principle because no work is being done on the system from the surroundings, and it is apparent because all of the forces add up to 0. The Python code can also be used to compare the experimental observed motion and the predicted motion of the mass. The predicted data is shown in blue, and the experimental data is shown in red. Through doing this, you can see the relative proximity between the model and experiment. The oscillations are shown in the y direction. The differences include the average period time. For example, for the oscillation time when using the y-axis, it is found to be 1.52 seconds, which is the oscillation time used. When using the x-axis, it varies slightly and is calculated to be 1.58 seconds. These could be affected by the forces of gravity. All of these observations reflect the main principles and prove that they work regarding the spring mass system. Thank you.